Okay, for this section, you're not being asked specifically if it's an independent or dependent event. You're being asked to calculate the probability of something happening. Okay, so you actually have to do some math calculations. So number one, we're pretending that your sock drawer has 4 white socks. Okay, so I'm going to write a 4. You have 6 brown socks, 6 black socks. So you've got 4 white socks, 6 brown socks, and 6 black socks for a total of 16 socks. Okay, so the next little part of this question is, it says you randomly pick 2 socks and get a matching pair of black socks. So our first sock that we close our eyes, we reach in, and we get a black sock. Well, there were 6 black socks out of 16 socks. And then you multiply it by the probability of the second event. So again, we're pretending we reached in, we got a black sock on our first draw. So there's only 5 black socks left, and there's one less sock total. For 5 out of 15 on your second event. So all you have to do is multiply straight across with these fractions. I know a lot of people hate fractions, but you just have to multiply straight across. But on the answer sheet, you're never going to see something like that. 30 over 240 is never going to be an okay answer for math class. So this one would be 12.5%, or if you got a decimal, that would be okay as well. 0.125 would be acceptable. Okay. So let's look at number 2 here. Number 2, we're flipping a coin twice. So again, when you flip a coin, you could get a heads or a tails, remember? And we're pretending that the first flip lands tails up, and the second flip lands tails up as well. So when you flip a coin, what's the probability of getting tails? Well, 1 out of 2. That's the first flip. First flip is a tails. And then we're going to multiply it by the probability of the second event. The second flip is also a tails. Well, that's 1/2. 1/2 times 1/2 is 1/4. This is an acceptable answer. Okay, reduced fractions are generally acceptable, but on your calculator that's going to be 0.25, which is also acceptable, or 25%. Okay, fractions, decimals, percents generally are always acceptable as long as the fraction is reduced. Okay, third example here is another coin flip, it looks like. You flip a coin, and then you roll a fair 6-sided die. Okay, when you flip a coin, there's 2 things that could happen. You could get a heads or a tails. And when you roll a 6-sided die, there's 6 things that could happen. Okay, 1, 2, 3, 4, 5, or 6. All right, so now let's read the question. The question here says, the coin lands heads up. What's the chance of getting heads? 1 out of 2, 1/2. And then the die shows a 2. Well, what's the chance of getting a 2? Well, there's 1 2 on a 6-sided die. Okay, 1 2 out of 6 sides. So 1/12 would be the fraction answer. The decimal would be, if you just did 1 divided by 12, you're going to get 0.0833 repeating, okay, which would be acceptable, or you can just say 8.33% would also be acceptable. Okay, that brings us to problem number 4. Okay, so a bag contains 5 red marbles and 8 blue marbles. So the first thing I do is I add those up. What's 5 plus 8? Well, that's 13 marbles in the bag. There's 13 marbles in the bag. Okay. Then you randomly pick a marble and return it to the bag before picking another marble. So the first one is red, the second one is blue. Well, how many red ones were in the bag? Well, there were 5 red ones. 5 out of 13. Remember, there were 13 marbles. And we're going to multiply that by the second event. Second event is that you're getting a blue marble. Well, how many blue ones were in the bag? 8. We did return it. We took the first red one out and we returned it. So we still have 13 marbles in the bag. So you multiply this and you get 40 over 169, which is actually reduced. So that would be an okay answer for a fraction. But as far as a decimal goes, it would be 0.237. Or you could say 23.7% would also be acceptable. Okay, it brings us to number 5 here. Number 5, it says there are 14 shirts in your closet. So we know it's out of 14 right away. Okay, the first fraction is going to be out of 14. 7 blue, 7 green. You randomly select one to wear on Monday and then a different one to wear on Tuesday. Okay, so Monday morning you get up, you select a shirt at random, you close your eyes, you pick one of your shirts. We're pretending on Monday you get a blue shirt, and then on Tuesday you also get a blue shirt. Well, how many blue shirts were there to start? 7. For the first day, for Monday morning, you got 7 blue shirts out of 14. Okay, but we're pretending that you get a blue shirt on both days. So how many blue shirts are left for the second day? Well, you took one away, so there's only 16. There's only 13 shirts left in the drawer because you took one away on the first day. So this comes out to be 42 over 182. And again, that's not reduced, and that's fine if you want to reduce that, but I'll tell you right now, mostly in this unit, it's okay to write decimals. 0.231 would be acceptable, or you could write 23.1%. But if you want to reduce that fraction, that would be okay as well. That would be 3 over 13 if you love fractions. But there aren't too many students who do. So decimals or percents are perfectly acceptable as well. Okay, number 6 here. Number 6, it looks like we've got a basket of fruit. There's 4 apples and 6 peaches. So how many total pieces of fruit are there in the basket? 4 plus 6 adds up to 10. There's 10 to start with. Okay. And now we're pretending you randomly select a piece of fruit and return it to the bag. So you take one out and you look at it and you put it back. Then you randomly select another piece. What's the probability that the first piece is an apple, the second piece is a peach? Okay, so here we go. Probability that the first piece is an apple. How many apples were there? There were 4 out of 10. Okay, we return it to the bag. So there's still 10 in the bag, in the basket. The second piece is a peach. Well, how many peaches were there? There were 6. So that's going to be 24 over 100. And again, if you want to reduce that, that's totally up to you. If you love fractions, you can do that. It's going to be 6 over 25 for the reduced fraction. 24% would be acceptable, or 0.24 would also be acceptable. So all of those solutions would be acceptable. Okay, so let's do 2 more, and then we'll call it good on these examples. So number 7, a cooler contains 10 sports drinks. So they tell you right away that there's 10 drinks in the cooler, okay? So that's what the first fraction is going to be. It's going to be out of 10. We've got 4 lemon lime and 6 orange. Okay, 4 lemon lime, 6 orange. You randomly grab a bottle and give it to your friend. Then you randomly grab a bottle for yourself. Okay, so you take one out, give it to your friend. You don't put it back. So you took one away, and then you grab one for yourself. So here's the question. What's the probability your friend gets a lemon lime and you get an orange? So your friend is first. How many lemon lime are in there? Let's see, there's 4 lemon lime. You took that one away, so there's only 9 bottles left. So you give your friend his lemon lime or her lemon lime, and then you grab your own. You're getting an orange. We're pretending you're going to get an orange. So there's still 6 orange ones in the cooler, in the container. So the second fraction is 6 out of 9. So this gives us 24 over 90, which again, probably isn't reduced. But if you want to try to reduce it, that would be 4 over 15, which would be acceptable. The decimal version, if you just use your calculator for that, the decimal version would be 0.267, or the percentage would be 26.7%. Okay, number 8. Okay, this one's a classic. You've got a deck of cards. Okay, you select 2 cards from a standard deck of cards. Standard deck of cards is 52 cards, remember. And we're asking what's the probability that you get both diamonds. Okay, now the problem reminds you that there are 13 diamonds. Okay. So remember, you're selecting 2 cards, and we're pretending that the first one is diamond and the second one is a diamond. So there are 13 diamonds to start with. That's your first draw. The second draw, you took 1 diamond away, so there's only 12 diamonds left. And you took 1 card away, so there's only 51 cards left. So this one is quite a bit messier as far as the fraction goes. That's 156 over 1092. And this is where you're going to notice it's just better to do decimals and decimals and percents. So you get 0.143 for the decimal, or 14.3%.